So we've studied some tricky negativity, and now it's going to get even trickier because, believe it or not, exponents can be negative. Well, let's explore this. Starting with the power of 2 to the second power. Actually, let's start with the power of 2 to the fourth, 2 to the third power. 2 to the third power is 8. We know that because 2 times 2 times 2 is 8. So what is 2 to the fourth power? Well, 2 to the third is 2 times 2 times 2. If I put another 2 in, I'm just multiplying 8 by 2. That gives me 16. Following this pattern, this one's 32. Oops. This one's 64, and so on. Powers of 2 are a good thing to know. Anyway, we get going from right to left, we're multiplying by 2 because there's always an additional 2 in the factors. So if I follow that pattern to the left, I may have started too far to the right. If I'm multiplying when I go to the right, I'm dividing when I go to the left. And it's true, 2 to the second is 4. This pattern is going down, 6, 5, 4, 3, 2, 1. And this pattern down here is dividing by 2. So 4 divided by 2 is 2, giving me 2 to the 0 power as 1. And I do want to take a quick aside to say anything to the 0 power is 1. And let's look down at this example. If I say x to the third divided by x to the third, some time ago in the snow days, we learned that when we are dividing monomials that have the same variable, we can subtract the exponents. So this is the same as x to the 3 minus 3, or x to the 0. We also know that any number divided by itself is equal to 1. All of those x's drop out. Therefore, any number, that's what x means, to the 0 power is 1. I want to pick up this pattern over here because I'm out of space. So let's start with 2 to the 0. We know that that's 1. And we knew that 2 to the first was 2. These exponents keep going down by 1. So the next exponent would be 2 to the negative first. 2 to the negative first. Sorry, that is so blurry. I'll rewrite that. 2 to the negative first. Well, in the bottom here, we're dividing. What is 1 divided by 2? 1 divided by 2. It's 1/2, otherwise known as 1 over 2 to the first. So 2 to the negative second would be 1/2 divided by 2, which is 1/4. And 1/4, 4 is 2 squared. So notice here, I can do one more. 2 to the negative third is equal to 1 over 2 to the positive third. What this means, any number, anytime, let's look at this one again. 2 to the negative third is equal to 1 over 2 to the positive third, which equals 1 over 8. What we would say using algebra is any number raised to a negative exponent is equal to 1 over that number to the positive exponent. So if I say 3 to the negative fourth, that means 1 over 3 to the fourth. And then I would say 3 to the fourth is 81, so that's 1 over 81. If I say 2 to the negative fourth, that's 1 over 2 to the fourth, which is 1 over 16. It is always 1 over, this number is the same, and the negative exponent becomes positive. So just finishing up this idea, this can have a few sort of tricky extensions. Let's just talk about 5 to the third power. Well, that's easy because the exponent is positive. That means 5 times 5 times 5, which is, I'm sure you know, 125. If I say 5 to the negative third power, that means 1 over 5, because remember this number doesn't change, the exponent becomes positive, which makes it 1 over 125. Similarly, negative 5 to the negative third power is 1 over negative 5, because this number doesn't change, but the exponent becomes positive, third. And a negative number raised to an odd power is negative, so that means it's 1 over negative 125, but that makes the whole fraction negative. If it were 1 over negative 125, when I'm dividing a positive by a negative, it becomes negative, and in fractions we put that negative sign out front. And here's the hard one to remember. Remember, this is read the opposite of 5 to the negative third power. So for now, we're just going to disregard this negative because we say the opposite of it at the end. So we say 1 over 5 to the third, because this number doesn't change and this becomes positive, so that gives me 1 over 125. And at the end, this negative goes out front. So notice that these are the same. They won't always be if you change the exponents or the powers. Let's do a different one where it won't be the same. Let's do the same idea with 2. 2 to the fourth power is 16. 2 to the negative fourth power is 1 over 2 to the fourth, which is 1 over 16. But if I say so now if I say negative 2 to the negative fourth power, that's going to be 1 over negative 2 to the fourth power, because these don't change. And negative number raised to an even power is positive, so that ends up being the same. But the opposite of 2 to the negative fourth power is the opposite of 1 over 2 to the fourth power, which makes it negative 1 over 16. With practice, it will all come to you.